Hello, I just wanted to run you through this rather beautiful machine that I have here. It is a RCM Tango with McGregor servos, nice big digitals in there, and I'm running it on a Taranis QX7. Who would have thought 20 years ago, oh, cat wants dinner, who would have thought 20 years ago that we'd be using a £100 radio to do the complex mixing required for one of these things. So just to let you know, just to show you just how complex these things are, I'm just going to power it up, and it's going to make a hell of a racket because they're nice big digital servos. But yeah, anyway, I'm going to show you what it does. Right, so there's three main flight modes on this thing. So we've got normal mode, landing mode,
normal, climb,
and climb.
normal,
Those are the three main ones that everybody uses. So what's happening is that, let's just show you one of these things. So in normal mode, we have the outboard ailerons moving. We also got the inboard ailerons flaps moving with them as well. Now that helps to move, helps with the aileron control, because they're, this is a 3 metre model, so there's a lot of wing to move. So they're moving together, and then obviously we've got V-tail. So you've got elevator and rudder, but then on top of that, when you move the elevator, you get a little bit of flapping, so the whole trailing edge moves with it, with the elevator. So up elevator is down, a little bit of down flap, and what that does is it increases the camber of the wing, increases the lift of the wing, and helps you pull around the corner harder. So it's especially good when you're racing, doing F3f and stuff like that. And then for climb mode, and then climb mode,
climb,
the whole trailing edge just drops a little bit.
normal,
So there's normal,
climb,
and there's climbing. So the whole trailing edge just drops a little bit there.
Normal.
Same thing with the snap flap. It just increases the camber, helps the solar model down, makes it much more manoeuvrable, flying in tight circles and stuff like that when you are eking out lift on a lighter day. And then with that, there is also
climb, normal,
separate trims for this flight mode as well, so that when you you can, the amount of the trim that you have, the elevator trim that you have in normal will be different to the elevator trim you need for climb, because that flap creates a little bit more lift. You need a little bit different trim, so you can trim that out as well on the elevator trim, separate trims for different flight modes. And then the landing mode. Now this is a really cool one I love.
landing,
So in landing mode, the throttle works to as your brakes. So as you pull the throttle back, see if I can show you this. As you pull the throttle back, the flaps go down and the ailerons go up. Now the flaps go all the way down. Sitting a bit low on that side, and then with that, the elevator also goes down a fraction as well, and that's tunable on, in this mode, it's tunable on what would be the throttle trim. So you trim it out with the elevator, so it's normal when the crow brakes, the brakes are away. But then as you bring the crow in, you fly it around, fly it on full brakes, and then you can trim using the throttle trim the amount of elevator compensation, because that has a huge effect over the elevator trim. All that flap and all those ailerons going up makes a huge difference. You need about 30% down trim, and that's tunable to the throttle trim with this setup. And then there's also a thing called
normal,
aileron differential. Now, because a wing has over the top surface, you have a lower pressure of air than you do have the bottom surface. That's how a wing works. That's how it creates lift. So, and what that means is that there's less air going over the top to cause drag. So when you move the ailerons, that upgoing aileron produces less drag than the downgoing aileron if it had the same amount of travel. And what that means is that if you have equal travel up and down on the ailerons, when you try and roll, it'll actually try and kick the model in yaw. So you'll get so if you roll left, you'll get a right yaw with the aileron input. So what you do is it's set up so that there's less downgoing aileron than there is upgoing aileron. And again, with this setup, with this program that I've got on the QX7 here, that's trimmable with the rudder trim, because you never use the rudder trim on these things. They're so accurate that you very rarely need to trim them at all on roll and yaw. Just a little bit of elevator trim depending on where the CAG is and stuff like that. So that's the idea of that. So you can then, and also that's also a separate trim for different flight modes. So also for climb mode, there's also a little bit of rudder kick, aileron to rudder as well, because if you look here, so when I move the aileron in climb mode, yes, of course, I don't have the ailerons hooked into the thing. So when you move the ailerons actually come up to centre first, which means at the same amount of travel you've got downgoing aileron, so you need a little bit of an aileron to rudder mix, but also you can have a different amount of differential in each of the flight modes as well. Makes it really, really, really nice to fly. And so you have different of everything pretty much across all the flight modes, and it's all just so easily programmable on a £100 radio. Now, like up until this software, the OpenTX software came along, you needed like a £500, £600, £700 radio minimum to do anywhere close to this sort of, even just to get 4 servos working, separately. And the other nice thing about this software is it's created by a guy called Mike Shellim, rcsaw.com, and he's done an amazing job of this software. The way you set it up, getting the mechanical geometry in these things right is very difficult. So you have to do all sorts of compensations for, because the two control surfaces won't move exactly the same and that sort of stuff. And the way he's got set it up to do the calibration is the servo calibration is really, really good. It's so easy just to get everything all moving the same amount in the same way. Even the flaps, they move. The calibration is done in such a way that that you can get the flaps moving together through their entire range, which in landing mode is such a huge huge amount of travel. If you've got any difference in travel between those two flaps, you get a roll trim change. Same thing with the ailerons. The ailerons coming all the way up like they do. Any difference in travel between the two sides, and you'll get a roll trim change as you bring the crow in. It just makes it so much harder to fly. Defeats the whole object of these beautiful things. Anyway, right. So that's my little run through of what an F3f model is set up is like-ish. And I'm loving this thing. It's come together quite nicely. They're never quite as simple as just throwing 6 servos in a model, especially when you come to the transmitter setup. But Mike's template has made it so much easier to get it up and running, and really, really sweet. Hopefully, maiden flight sometime next week. Fingers crossed.